Good morning, Davao de Oro. Good morning, Z-eskwela listeners, especially to all grade 8 students who are listening to us right now. I am your radio teacher, Miss Suchmita Dayanara and Relampagos from Andap National High School, New Bataan District. And together with me is Mr. Eliezer M. Bukas from Monte Vista National High School, Monte Vista District. We are here happy to serve you for 45 minutes of bringing you with fun and exciting lessons in Science Grade 8. So, what are you waiting for? Sit back, relax, and join us as we discuss our new lesson, which is about earthquakes, epicenter, and magnitude. Once again, we are here to bring with you another lesson in science, and we hope you had already prepared your pens, record notebooks, and modules. And be sure that you already had eaten your lunch as we go through our discussion. So, are you ready for today's lesson? That's good! If you can recall, in Science 7, it was mentioned that the Philippines is situated along the Pacific Ring of Fire. How does this affect us? Well, people who live along the Ring of Fire must anticipate the occurrence of earthquakes and volcanic eruptions. In Module 1, it was discussed how the movements of faults generate earthquakes. So now, let's have a review about faults and earthquakes. First, let's recall what is an earthquake. Earthquake is the shaking of the surface of the earth resulting from the sudden release of energy in the Earth's lithosphere. The energy will eventually be released once the fault overcomes the friction movement. How about faults? Faults are thin zones of crushed blocks of rocks. These are often in centimeters to thousands of kilometers long. Their surfaces can be vertical or horizontal. These can expand into the earth and might possibly reach out up to the earth's surface. These are also breaking in the earth's crust, where rocks on either side of the crack have slid past each other. There are three kinds of faults. We have the strike-slip, normal, and thrust or reverse faults. Each type is the outcome of different forces pushing or pulling on the crust, causing rocks to slide up, down, or past each other. The amount of ground displacement in an earthquake is called the slip. Now, let us discuss the three kinds of faults. Let's start with strike-slip faults. How will you describe a strike-slip fault? Strike-slip faults are rocks sliding past one another on a horizontal plane with little to no vertical movement. Examples of this are San Andreas Fault and the Anatolian Fault. Next is the normal fault. What is a normal fault? Normal fault are two blocks of crust layer pulling apart, extending the crust into a valley, thus creating a space. A normal fault has the upper side or hanging wall appears to have moved downward with respect to the footwall. The Basin and Range Province in North America and the East African Rift Zone are two notable districts where normal fault is spreading apart Earth's crust. Lastly, the thrust or reverse faults. How will you describe this kind of fault? Reverse faults are also known as crust faults. The slide of one block of crust is on top of another. These faults are normally found in collision zones where tectonic plates push up mountain ranges. For example, the Himalayas and the Rocky Mountains. In addition, when rocks slip past each other in faulting, the upper or overlying block along the fault plane is known as the hanging wall or the head wall, and the lower block is known as the foot wall. You also have to remember that strong earthquakes have caused countless deaths all over the world, even before people have started recording these events. These are unpredictable forces of nature, and they happen in no specific time and place. Up to this day, seismologists are still figuring out how to detect seismic tremors accurately. No one can stop earthquakes from happening. But there are things that people can do to avoid or decrease the loss of life and damage to property. The first step is to have a clear understanding of the occurrence of earthquakes. There you have it, our previous lesson, which is all about faults and earthquakes. Now, we are done with our review, and to test your prior knowledge on today's concepts, kindly open your module on What I Know, page 2 to 4, and let's try to answer some guide questions. Now, let's read the instruction first. Choose the letter of the correct answer. Write your answers on a separate sheet of paper. Number 1. Where is the epicenter located in the illustration? A. Number 1. B. Number 2. C. Number 3. Or D. Number 2 and 3. Answer. Letter B. Number 2. What point on Earth's surface is directly above the focus? A. Epicenter. B. Fault. C. Focus. D. Magnitude. Answer. Letter A. Epicenter. Number 3. What is focus? A. Center of the Earth. B. End of the seismic waves. C. Surface of the Earth where the wave starts. D. Location where an earthquake's waves begin. Answer. Letter D. Location where an earthquake's waves begin. Number 4. Which of the following describes an active fault? A. No earthquake occurs. B. No record of earthquake. C. Expected to generate earthquake. D. Generates earthquake once in a million of years. Answer. Letter C. expected to generate earthquake. Number 5. Which point is closest to the epicenter? A. Point A, B. Point B, C. Points A and B, D. Points B and C. Answer: letter B, point B. Number 6. What scale measures the magnitude or size of an earthquake? A. Mercalli scale, B. Richter scale, C. Spring scale, D. Weighing scale. Answer: letter B, Richter scale. Number 7. What is referred to as a measure of the amount of energy released in an earthquake? A. Intensity, B. Magnitude, C. Stress, or D. Tension. Answer: letter B, magnitude. Number 8. Which of the following statements refers to the magnitude scale? A. It measures the effect of an earthquake on a given area. B. It is a negative impact of the earthquake on surrounding areas. Letter C. It is the devastation caused by an earthquake varies with location. Or letter D. It is the quantified value of seismic energy produced during an earthquake. Answer: letter D. Number 9. What is the description of a 5.0 to 5.9 magnitude in a Richter scale? A. Light, B. Major, C. Moderate, D. Strong. Answer: letter C, moderate. Number 10. In which of these places will an intense earthquake likely happen? A. Near a mountain, B. A long active fault, C. Near coastal area, D. A long inactive fault. Answer: letter B. Well done, learners! I guess you are now ready for our next lesson. What do you think would be our lesson for today? This time, we will discuss with you another lesson which is about earthquakes, epicenter, and magnitude. We hope that you will be able to achieve our objectives for today. What would be our objectives? At the end of this session, you will be able to differentiate the following: A. Epicenter of an earthquake from its focus, B. Intensity of an earthquake from its magnitude, and C. Active and inactive faults. So, are you now ready to listen? Fabulous! Now, sit back and relax, because after a short break, we will start our lesson.
The Radyo Z-eskwela program of the Division of Davao de Oro is being brought to you by Nueda Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Archicons Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
I'm back, learners. This time, we will discuss about earthquakes, epicenter, and magnitude. In this lesson, we will differentiate the following. A. Epicenter of an earthquake from its focus. B. Intensity of an earthquake from its magnitude. And C. Active and inactive faults. Now, let's start with the fault. How will you describe a fault? A fault is a weak point in the tectonic plate where the pressure inside the crust is released. How about the focus of an earthquake? The area inside the earth where an earthquake starts is known as the focal point of the quake or the focus. It is centered on the portion of the fault that has the greatest movement. On the other hand, the point at the Earth's surface directly above the focus is known as the epicenter of the quake. During an earthquake, the strongest shaking occurs at the epicenter. Sometimes, the ground surface breaks along the fault. There are also times the movement is deep underground and the surface does not break. Scientists often name an earthquake after the region that is closest to its epicenter. Generally, if two earthquakes of equal strength originate from the same epicenter, the one with the shallower focus causes more destruction. Seismic waves from a deep focus earthquake lose more of their energy as they travel farther up the surface. Now, let's move on to the magnitude and intensity of an earthquake. The earthquake's magnitude and intensity have different characteristics. First, let's discuss magnitude. How will you describe it? Well, magnitude measures the energy being released from the origin of the earthquake. It is measured by an instrument called seismograph. The Richter magnitude scale measures the quantity of seismic energy released by an earthquake. Let's try to look at the example found in your module on page 10. The first column tells about the magnitude of an earthquake. The second column tells about the description of the magnitude. The last column pertains to the effects of earthquakes. Now, let's try. What is the description of magnitude 5.0 to 5.9? Very good! The answer is moderate. How about the effect of magnitude 7 earthquake? You are correct. Magnitude 7 can cause a major damage over larger areas. Do you understand now how to use the Richter scale? Fabulous! This time, let's move on to the intensity. How does it differ from magnitude? You are correct. Intensity is the strength of the trembling made by the earthquake at a place. The intensity of an earthquake varies relying on where you are and is determined by the Mercalli scale. Now, let's try to look at the intensity scale of an earthquake found on your module on page 11, and let's answer the following questions. What is the weakest intensity scale? Very good. It is the intensity 1. How about the description of a destructive intensity? You are correct. The answer would be most people are frightened and run outdoors. People find it difficult to stand in upper floors. Heavy objects and furniture overturn or topple. Big church bells may ring. Do you understand now the difference between magnitude and intensity of an earthquake? Very good! At this point, we will differentiate another terms which are the active and inactive faults. A review about faults. Faults are breaks in the weak parts of the Earth's crust. It has three kinds: the strike slip, reverse, and normal faults. How will you describe an active fault? Active faults are areas along in which displacement is expected to occur. Since a shallow earthquake produces displacement across a fault, all shallow earthquakes occur in active faults. It will possibly be the cause of another earthquake soon, and considered as to be geologic hazards. While inactive faults are areas that can be identified, but which do not have earthquakes. It does not show signs of generated earthquakes. There is no displacement of geologic structures in an area. Well, that's all for today, grade 8 learners. We are finally done with our discussion. So, I guess you are ready now to take the quiz. After this short break, kindly prepare any sheets of paper for our evaluation. Good luck and God bless!
The Radyo Z-eskwela program of the Division of Davao de Oro is being brought to you by Nueda Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Archicons Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
I'm back, learners. Are you now ready for your quiz? I guess you are quite ready and excited. Learners, kindly open your module on assessment part, pages 15 to 17. Let us read the instruction together. Choose the letter of the correct answer. Write your answers on a separate sheet of paper. Number 1. Where is the focus located in the illustration? A. 1, B. 2, C. 3, D. 2 and 3. Number 2. At what point along a fault does the first motion of an earthquake occur? A. Epicenter, B. Focus, C. Intensity, D. Magnitude. Number 3. Where is the epicenter located? A. Directly above the focus, B. At the center of the earth, C. Located in the seismic waves, D. Located underground where the earthquake begins. Number 4. Which instrument determines the amount of damage caused by earthquake? A. Spring scale, B. Richter scale, C. Mercalli scale, D. Weighing scale. Number 5. What is the highest intensity scale of an earthquake? A. 8, B. 9, C. 10, D. 11. Number 6. Scientists use different ways to find out if a fault is active. Which one is not included? A. Creating a fault model, B. Observing the surroundings, C. Tracing the country's historical record, D. Studying the past and present vibrations. Number 7. Which point is nearest to the focus? A. 1, B. 2, C. 3, D. 4. Number 8. Which of the following locations is directly above the focus? A. Core, B. Epicenter, C. Fault, D. Hypocenter. Number 9. What is the magnitude of an earthquake that can cause serious damage in areas across several hundred miles? A. 5.0 to 5.9, B. 6.0 to 6.9, C. 7.0 to 7.9, D. 8.0 to 8.9. Number 10. Which of the following is not considered an effect when movement of an active fault happens? A. Ground motion, B. Typhoon formation, C. Surface faulting, D. Land deformation. Okay, let us check your work. Number 1, C. Number 2, B. Number 3, A. Number 4, C. Number 5, C. Number 6, A. Number 7, C. Number 8, B. Number 9, D. And number 10, B. Who among you got perfect? Very good! How about those students who get below the median? Good! Nothing to worry about because we still have plenty of assessment. Once again, Congratulations, everyone! Again, we hope that you were able to differentiate the following: epicenter of an earthquake from its focus, intensity of an earthquake from its magnitude, and active and inactive faults. Once again, thank you so much for listening and see you on next session through radio-based instruction. I am Sushmita Dayanara and Relampagos from Andap National High School, and together with me is Sir Eliezer M. Ribucas from Monte Vista National High School for the class on the air in Science Grade 8. For those concepts which is not clear to you, you can put your comments, suggestions, and questions on our FB page. Thank you so much.
Radyo Z-eskwela Executive Committee. The School's Division Superintendent, Eufemia T. Gamutin Seso 5. Assistant Schools Division Superintendent, Dr. Romel R. Handayan. OIC Curriculum Implementation Division Chief, Karina S. Frasco. School Governance and Operations Division Chief, Dr. Ruben J. Riponte. Members: Cecilia Morales, Dr. Hilda A. Opeña, Dr. Arlene B. Lim, Dr. Eldecris B. Calzadora, Dr. Dexter A. Siquinia, Nohara O. Pinute, Noemi P. Canales, Dr. Grace D. Pontillas, Virgilito C. Pabrices, Juanito Lapiceros, Engineer Norberto S. Manlangit, Jomar M. Dumupoy, Bob Dalan S. Milabat, Medard T. Ampit, and Paz Eugenia Villusino. Technical Working Committee. Productions and Communications, Lorely E. Quijano, Given G. Hinampas, Judyland T. U, Donna D. T. Bolifer, Mary Rose N. Resma, Riwen Manuel, Irene Lea C. Manguhon, and Bessie Aya N. Banias. Social Media and Packaging Team, Christian Anhara L. Martesio, William R. Ranara, Joan T. Iscoton, Roberto S. Acusar Jr., May B. Istaniol, Richard H. Arellano, Glee L. S. Blanco, Ralph A. Tabanyag, Angelo Gutierrez Jr., and Jade Karen Araiz.